everyone. So today I'm very honored to be here to introduce Satellogic. And Satellogic is a leader in high-resolution Earth observation data collection. Using AWS, they are able to streamline access to critical information about our planet. Ryan McKinney is the president of Satellogic North America. Prior to this, he was head of strategic initiative at DCARS Labs. DCARS Labs focus on provisioning multiple global remote sensing modes of data on an automated planetary scale platform. And it provides multi-module applications using AI/ML models and algorithms for rapidly advanced analytics. So we'll welcome Ryan to give us a presentation about Satellogic.
Thank you all for joining us. I know it's late in the day, and I appreciate you guys coming and sticking around for it. And hopefully you find some of this information valuable. I'd like to start out with our video here.
Changing planet. How will we feed 9 billion people? How will we generate energy without damaging our planet? How will we manage the changes on Earth? At Satellogic, we have reinvented the satellite from the ground up to create a smaller, lighter, and more cost-effective system that can be produced at scale. We are building the first scalable Earth observation satellite constellation with the ability to remap the entire planet at high resolution, capable of providing diverse and rich geospatial data at unmatched frequency, resolution, and cost. Born in 2010 as a global venture, we are the first vertically integrated geospatial analytics company. We design and build all the components of our satellites, including sensors, systems, onboard computers, and our unique patented cameras. We integrate all these components at our state-of-the-art AIT facility in an agile and scalable work cell manufacturing process based on the 5S and Lean methodologies. The continuous renewal of our fleet allows us to fly up-to-date technology. We operate our satellites and collect high-resolution imagery for monitoring economic activity and high-frequency changes that include object identification, classification, and change detection, among others. Our customers turns this into answers to deliver end-to-end solutions for a broad range of industries to facilitate decision-making and drive competitive advantage.
To start out again, my name is Ryan McKinney, and I'm the president of Satellogic North America. My background, though, is nothing to do with geospatial data. In fact, I actually got my start on IT security side, so focused more on IT security, software, hardware. But eventually I ended up wanting to get tied into understanding risk and essentially leading more into the cyber risk component. And this is where I started to understand that there's other things in the world besides just the hardware and software, and you need a lot of data in order to tell the true story. And so from evaluating cyber risk, I started to understand that you needed these technical facts and you needed these non-technical factors in order to really begin to tell the whole story. So after going through cyber risk for a few companies, I ended up moving over into the geospatial world, mainly because I felt that there's this opportunity to take geospatial data, a data set that was typically for defense and intelligence purposes, and start to incorporate that into business decision-making processes outside of the US government. What we're seeing right now is the demand for insights based off of geospatial data is continuing to increase. But we're seeing the reasons for that are like probably about 3 different buckets that you could put that into. One of them being, when you look at what NASA and the European Space Agency has done to open up data sets like Landsat and Sentinel, you begin to have ways for people to try new things and see what is possible with data that's coming from space. You also start to see the interests have changed. So what used to be just government-based data sources around climate change, humanitarian crisis, natural disasters, you're starting to see businesses care and wanting to find ways to get their own data for that type of analysis. And then, you're also starting to see as capacity continues to increase, you're beginning to see new and emerging use cases where people are integrating this type of information on a large scale. But what that means is we now have a couple of challenges. One of those being demand is increasing, but the current capacity won't meet future growth. So there is a demand for more capacity. There is a demand for us to find better ways to get access to space-based data down to the customer. But the other part of this is customers can get quickly overwhelmed with the amount of data that's coming down, especially if they're not sure what it is they're looking for or exactly have a good understanding of how much data they're actually requesting. So what we have to do is we have to help our customers understand what it is they're asking, what's the use case, and what's the data set that's required for that. We rely on AWS to help us not only put our data where it needs to be, but also put it where our customers need it to be. So a little bit about Satellogic. We were founded in 2010. That does make us part of the new space, but I do kind of joke that we're not that new. We've been around for a little while. Our founders started the company because they had a desire to bring valuable space-based data to non-traditional users. The early years were spent designing and building prototypes, but also listening to consumers of this data, right? So the people who have been using this data for decades, what is it that they like about this data? What are the dislikes about the industry? And then we also spent a lot of time with those who haven't incorporated this data. And the purpose behind that is understanding why. And really coming out of those conversations, we began to really understand where we thought we could provide value and some very specific things that we want to be able to do in order to meet the demands of our customers. So, one of the things we wanted to be able to do is improve satellite manufacturing. How can we keep costs low without the integrity of the data or the quality of the data being compromised? One of the things we heard both from seasoned veterans of using this data and those who are still novices is the cost of the data was too high. So what we wanted to be able to do is figure out how can we reduce those costs to make the data affordable to broader audiences. The next phase of this, and this makes sense, but imagery licensing has been a problem for years in the sense that the traditional use cases coming out of intelligence meant I want to see an image, I need it, and I don't want anybody else to know what I'm doing with it. So a lot of the licensing structures were set up to support that. However, that's not how data is being used today. So we needed to find ways to make our data accessible, understanding that we wanted to increase collaboration based on inputs and insights that are coming out of our data. And then finally, how do we reliably deliver this data where the customer wants it to and at scale? So right now, Satellogic has 26 satellites in orbit. We have 4 more going up, hopefully before the end of the year. I can never give a date because they always change. But we're hopeful that those 4 will go up, and then we try to launch every single quarter. A little bit about Satellogic North America. This is my division. We were purpose-built to support US government, Canadian government, and NATO. What that also means is we're supporting those partners that are building derivative products, building models to support those entities. We're a wholly owned subsidiary of Satellogic, and we are purpose-built just to support that core set of customers. So commercial Earth observation is essential intelligence source for energy, finance, agriculture, and governments. Providing imagery over areas of interest on a regular cadence allows both public and private sectors to monitor activity levels and derive insights on things that impact them, like food security, economic indicators, or supply chain disruption. One image can certainly provide you, information that can be valuable across, a whole host of different use cases. You can certainly build machine learning algorithms that count containers and look at the size of vessels and estimate the amount of cargo. But what we're seeing is there's a need for more than just that single image over a single location. So what you're seeing here is a stack of 8 Satellogic multispectral images over the same location over roughly about a 2.5 to 3 day period. And what this does, and the reason why this is valuable, is as the cadence increases, so does the accuracy of the model. That's what we're seeing from our customers. So the fact that they have the ability to get access to multi-day revisit imagery means they're getting better situational awareness about what's happening at these facilities. So our constellation offers our clients the opportunity to answer questions like these for ports all around the world. They can look at things like identifying the changes that may impact this port, monitor risk factors, look at things that that could potentially put this facility at risk. The other element to this, though, is to think about the same data set, look through the eyes of somebody from a different perspective, somebody who maybe is not interested in the business aspect of this, but perhaps the environmental. They can start to look at things like tides. They can look at wave height or wind direction or speed, and perhaps even start to look at what the signature would be for oil detection if there were a leak from one of these vessels. Our constellation provides high revisit, high resolution data anywhere on the planet. So we're looking to unlock all sorts of use cases. We rely on AWS to put our data in our customers' hands securely and when they need it. So this is a pretty typical slide that you'll probably see from anybody who does what we do. None of this is new. People have been using Earth observation data for decades. What's emerging and what is new are the number of people requesting access to this data. The types of users are changing. It used to just be as an analyst sitting in a dark room. That's not the case anymore. You have people who have no geospatial background wanting to be able to derive insight from this data. And I think that ties into the other side of this, is the emerging piece to this is how the data is being used. We're continuing to see new ways in which our data is being used today. So commercial space industry makes it possible to gather information over areas of interest on a planetary scale. But not every customer needs to monitor every port on the planet or every airport. But it doesn't mean that their reasons for needing the data is any less important. So our job is to have the data they need when they need it. It's our job not to limit their ability to gain insight, but to enable it. And so by partnering with AWS, we make sure that we can stay focused on providing the quality data that we provide and work with AWS to make sure we're delivering this where the customer wants it to be. Monitoring energy, and actually energy companies were some of the first early adopters of using commercial space-based data. Our clients today are using this data to monitor construction progress of new facilities, assess the operational efficiency, or potentially even detecting risk factors that might have an impact on safety or supply chain disruption. But what happens when you want to monitor hundreds or thousands of facilities around the world? It quickly can become overwhelming. One facility going offline will certainly have a regional impact, but if multiple locations go offline, it has that global impact, right? So, one of the things we used to think about on the insurance side is what happens when a cyber event causes a physical event, and how can you monitor that? So some of the things we used to think about were industrial control systems or SCADA devices. If there was a vulnerability in that somebody could exploit and have some sort of kinetic event happen in the facility, how would you monitor that? How would you monitor if something like that's happened? How would you monitor if it's offline? How would you monitor if it's actually back up and running? If you had to send an individual out to hundreds or thousands of these locations, it could be quite difficult. So this is another use case for space-based data in a commercial environment. The other element to this too is, and I'm sure you could imagine, that the same data through the eyes of somebody who's looking at this from an environmental impact can certainly start to look at what happens if there's a spill. What happens if there's something that does cause a kinetic event that causes damage. And we rely on AWS not only to help us deliver our data, we also we have AWS work with us so that we can scale up or scale down depending on the customer's needs. They may not need data over every refinery, but it doesn't mean that they don't have a requirement and that it's not important to them. We need to make sure that we're able to support those needs. Ooh, there we go. The other element to this, I think we've seen quite a bit, is the importance of data delivery on time. I think you start to limit the use of the data when you're not meeting the needs of the customer around time and latency. So being able to deliver efficiently is critical for our customers, and sometimes the customers, not just the customers, but also who our customers are serving. And so in events that are unfolding, like the withdrawal in Afghanistan, a lot of that initial data, the capacity was sort of all for military use and intelligence use. And of course it should be, but I think at the same point, this means that there's a risk for NGOs and other organizations that need this data, but may have less access to it. So we were fortunate enough to share our data with humanitarian organizations that tangibly aided in the safe evacuation of citizens during this catastrophic event. It isn't always possible to predict when and where the next event will occur. But it's clear, I think, that commercial Earth observation data and imagery will play an ever-increasing role in helping us understand what is happening on our planet and increase awareness, not just for governments, but for citizens. The ability to monitor construction sites is also something that I think we're beginning to see happen more and more. We're seeing folks that are trying to manage complex, large-scale initiatives and having an understanding of what's happening on the ground. When you have the ability to look at these projects, and for instance, if you needed to identify roads, you can see in some of these roads, they're dirt. Some of them you can see they're asphalt. But you probably need to figure out where they are and are they in the places you need them to be. Because if you're going to the next phase of a project and you've got heavy equipment that needs to get in and the road conditions need to be right and all of these things need to take place before you move forward, you don't want to start sending that stuff out until they're ready to support it. So these are just some of the ways that developers, suppliers, and governments are tracking these large, sophisticated projects. But others may see this data as a way to start monitoring environmental impact. What impact is this development having on the region? As you can imagine, in Saudi Arabia, things like water resources and other resources may be pulled from areas surrounding this, and what's the impact on those living in those environments? So this is just another example of how data over locations like this can be important to more than just a business use case. So perhaps the most prolific example in widespread use of commercial EO intelligence in monitoring Russia's invasion in Ukraine. It's widely accepted, I think, that the war in Ukraine has been the first major conflict where commercial space has played a serious role. And I think what we're starting to see is that it's a key role in helping us understand things, not necessarily looking at specific troop movements or trying to look at things that perhaps are more on the classified, but just having an ability to sort of be a checks and balance. I think we saw this on a couple of different occasions, very early on when there were talks about, what's happening and is Russia going to attack? It was easy for narratives to get out, oh no, they're training exercises, right? But there was enough data for us to realize that doesn't look like a training exercise. There were also conversations about, what's happening in the ports. Are they restricting ports? Are they removing grain? Well, yeah, they're removing grain. We have pictures of it. We know they did. Right. So it's really important for us not necessarily to get caught up on whether or not the imagery is something that can be used. I think we all know that it can be, but now it's being able to figure out what are the use cases that provide the biggest impact. So in order to provide valuable situational awareness in scenarios like this, we have to have the ability to monitor large areas multiple times a day. And that's one of the unique capabilities of our satellites. We have the ability to take very, very long stripes. We can actually capture multiple targets in a single stripe. It also requires us to get this data into the hands of those who need it most, both securely and at the rate of collection. Without our partnership, honestly, with AWS, I don't believe we'd be able to support them because we'd have to spend so much more time building infrastructure to try to deliver. And fortunately, we can just leverage AWS. But I think it's also really important, I think we think about high cadence use cases. We think all of these are focused around situational awareness with defense sort of in mind. But that's not the case. When you start thinking about humanitarian efforts, you have to start thinking about ways that this data can provide value as well. So, casualties of climate change continue, as well as conflict, continue to increase. And the need for situational awareness is as well. So we were fortunate and are fortunate to support MIT's Lincoln Labs in the development of their product known as the Humanitarian Notification System. And we're providing imagery on locations and refugee camps so that we can help provide better understanding of what's happening on the ground for those who are supporting displaced people and those who are trying to get goods, medical devices, and medicine to these camps as well. What we found is, there's also a need that if you're alerting, military forces that are in this area, you're able to start telling them, there's a camp here. This area is off limits. And you start to put them on notice on what's actually happening and that you're actually watching as well. The fact that we can revisit multiple times a day, I think, is very important in things like this because, as you can imagine, displaced people move and it's not always predicted. But if they know if there's areas of people concentrating, it's going to change over time. And so you have, an image a week is not going to give you the right understanding of what's happening on the ground. So this is an image in Ethiopia, and that really was used a lot for logistics planning. I mentioned roads, right, and understanding road conditions. Well, when you have a camp this size, you need to find ways to get water and goods and food and services into this. And if the road conditions aren't good, then bringing them in on a truck is not going to help. So you need to be able to assess, really what the situation is on the ground. So a little bit about, what is our relationship. I think I've highlighted a few different things, but I'll get into it a little bit more. I recently met with one of our customers on the North America side that said, when he talks about or thinks about ingesting the planetary scale data that he needs for his use cases, it's a little bit like drinking from a fire hose. And, for a U.S. government entity to make those types of comments, you can only imagine somebody without those resources trying to do it. When you're monitoring hundreds of thousands of locations, you need all the data, but it can be overwhelming. And if it's overwhelming, then you're not getting the full value. So we depend on AWS to provide massive amounts of important data to all of our customers, but only when they need it and are ready to consume it. So AWS's Lambda service provides a cost-effective architecture for us that can fulfill web service requests at scale without the need to provision a single virtual machine. What that means for us is nothing is just sitting around waiting to be used. We can spin up as necessary, we can spin down as necessary. And that Lambda service is critical service for us. It makes us much more efficient and allows us to do more with less. So that serverless architecture and the ability to automate these services mean I can decrease the human in the loop, which then means there's an efficiency advantage as well as a cost advantage. And certainly that's part of passing that along to our customers. And to go back to the beginning of the presentation, one of our key elements is how do we keep the cost of our data low without sacrificing quality. So when we look at customer benefits, I kind of look at our relationship with AWS kind of like a relationship. So if you have trust through a relationship, if you have a trust that they're going to be able to deliver and do what they do, then you can go focus in other areas that are important to your business. And we certainly look at it that way. Because we trust AWS to scale with us and scale with our partners, we can focus on our technology. We can make our improvements on our data, spend less time worrying about how to get the data to our customers. Our customers receive from us data they can trust. They receive to us high quality, high resolution, high cadence data at the lowest price point in the market. So that for us, AWS helps us keep our costs low, both operationally, but it ends up passing through to the customer. So that's part of the benefit. The success of Satellogic is contingent upon our ability to get our data in the hands of those who are creating new ways to derive insight. Our data is being used by geospatial experts around the world that have been using data like this for decades, and that's certainly important to us. And quite honestly, that's a lot of my customers within the US government and Canada and NATO. But it's equally important for us, and in fact, I'd say almost more important for us that we expand this market. So we need to find ways to get data into the hands of those who have less experience with it and need to be able to get access to this data. We want them to try new things. We want to enable them to fail quickly or succeed quickly, but do so and not break the bank trying, right? We want them to be able to get this data and try new things. To accomplish this, we need to do a couple of different things. One, we need to promptly and securely deliver our high-quality planetary scale data to our customers where they want it and when they need it. We need to be spending our resources on our capital, on improving space-based data gathering capabilities and focus on the technology. So how do we improve the resolution is obviously something that we need to spend time on. We're sub-meter now, but of course we want to be better. We want to advance the sophistication of our sensors. We want to think about things, there were comments and things that are happening around edge processing, and we're currently doing edge processing in space as well. But we need to be able to do all of these things and all of these sophisticated, complex things, but not outprice the customer, because otherwise we start going right back into traditional use cases. So we have to stay very focused on how we keep our data at a high level of quality, but also at the right price point so people want to access it. AWS is critical and very active partner in our organization's success, ensuring we can stay focused on really supporting our customers. We really try to be very customer-focused, very mission-driven, and so by not having to worry about what's happening with our data, it allows us to focus more on the customer. So satellite imagery isn't a new phenomenon or some sort of emerging technology. Satellites have been collecting data for decades, and people have been analyzing data for decades. What is new, though, are the number of satellites entering low Earth orbit. There's more and more going up, and with that, more use cases become unlocked. But there's also concerns around that. I think we all understand that space, the environment that we're operating in low Earth orbit is getting congested. But this is something that Satellogic's been thinking of from day one and has really kept sort of front of mind. So when we build our satellites, they have about a 3 to 5 year lifespan. And they're constantly orbiting, constantly delivering us data. But at the end of their life cycle, their final mission is to point towards Earth and burn up and leave no trace. This is part of our constellation sustainability and management strategy. So we do this in order to make sure that we're being good stewards of the environment in which we operate, but also to make sure that we can continue to provide the type of data that we need to for our customers. We want to enable the development of new use cases and solutions that can make our planet safe and secure for generations to come. That's not going to happen if we're pricing the data in a way that the only people who can access it are people with large budgets to support this type of insight. So, I think with us, the importance of AWS is critical in our ability to keep our data costs low, our overhead low, and be able to provide this data at scale. And they scale with us. So that's it. I'm happy, we're a small audience. If there's questions, we can either take them now or you can find me around here. But, any questions, I'd be happy to take them.